I'm CK with Under Pressure and Power and Performance, and today we're going to go over relays. I'm going to explain a little bit how they work, what they do, and what we use them for. That way we got a better understanding of how to use them, how to connect them, and why they do what they do. Alright, so this is a normal 5-pin Bosch style relay that we're talking about today. And here's the schematic of it basically laid out. You've got 3 pins that go in the same direction, that's 85, 86, and 30. And then 2 that are perpendicular, and that's 87 and 87A. Now there's going to be 3 main uses that we're going to be talking about today as far as what we're using the relays for. One is going to be an amplifier, one is going to be a logic circuit, and one is going to be a power inverter. Alright, so let's go ahead and get started. The first use that we're going to use it for is going to be an amplifier. Basically what that means is if you've got a little tiny micro switch and you want to use it to control, say, your starter. Your starter pulls a lot of amps. That tiny micro switch probably can't pass enough amps through it. Therefore, if you do try and wire it up where you just have a switch that's too small for the circuit that you're using, you're going to burn it up. It'll actually melt the switch. Sometimes it'll actually even cause a fire. So in order to alleviate that problem, or to have things with less amperage, like your ECU for example, control something bigger like a fuel pump, we'll put a relay in between. Now the relay is going to act like an amplifier, just like your normal car audio amplifier. Your stereo passes out a very weak bland signal to your amplifier. Your amplifier takes that, multiplies the signal, and pushes it out to subwoofers, which then have a lot more power, but are outputting the same signal that the stereo originally was. That's kind of how this is going to work. Basically it's like a switch, except it's a switch that's controlled electronically. So instead of a normal toggle switch like this that we might have, it's a toggle switch that operates electronically. Now if we look at pins 85 and 86, those are going to be the 2 that are parallel with each other, yet directly opposite. If you're looking at the other side, they're perpendicular to each other when they're opposite. These 2 are going to be your triggers. Basically, what it is inside of here there's a magneto coil, and when you apply voltage to it, positive on one side and negative on the other, it energizes this coil. When you energize the coil, it shifts and makes a connection on the circuit here. So these are our triggers. It doesn't matter the polarity on them, so you can use a negative on here and a positive over here, or you can use a negative over here and a positive over here. It's really irrelevant. They work the same, but you just have to have one of each on each side. Now, for the other poles, those are going to be the 2 that are opposite from each other, but that are perpendicular. These are 87 on the top here, and 30 on the bottom. These 2 are your switch, essentially, what you're waiting to make the connection with. So, once there's a positive signal here and a negative signal here, whatever you're applying at this point can pass directly through and go out at that point. If you erase one of these here, you break the circuit in between and nothing gets outputted. So this is what we're actually going to call our pass-through line. Now, the way we would wire this up in a system, something very common that many of you guys are probably watching this for, would be either our fuel systems or our turbo kits. They require hooking up a relay for it. Now right now we're only using 4 pins of this relay. I'll come to the 5th pin a little bit later on, but right now we're just going to concentrate on the 4. So for the relay, for our trigger, we're going to hook up one right to a ground. That's just going to ground that out. Our other trigger, we're going to hook up, and this is going to go to an injector 12-volt plus wire. So that is those wires that go to the injector on the LS engines. You guys are going to see they're usually a pink wire. When you key it on, it's got positive 12 volts going to it. What that's going to do is every time we activate our ignition system, it's going to power this relay up and it's going to complete the circuit between here and here. Now, the reason we don't just tap off of this here is, again, the power circuit going to this injector wire does not have enough power to run anything significant. So when we go to connect our oil return pump, that doesn't have enough amps to run the injectors and our oil return pump. So we're going to put the relay in between. Now, number 30 here, we're going to come off and we're going to go ahead and call this our input. And input to output between 30 and 87, there is no difference. You can switch it around. It's the same. There's no polarity on it. You can pass positive through it. You can pass negative through it. This could be your input. This could be your input. It's irrelevant. All we're doing right now is making a circuit connection between these two. So when we have negative here, which is going to be all the time because we just grounded it, an injector input, which is when the key is on, our input, which is going to come from our battery, so we got plus 12 volts, and remember, you're going to want an inline fuse in there. That's going to keep our circuit safe. Plus 12 volts will now output out of 30 here, and that is going to run over here to our pump. And that's a basic amplifier circuit for one of these. So again, as long as you have a positive and a negative trigger, whatever you have on your input is going to go to your output. And that's the most basic way that we have for hooking up a relay. And it doesn't matter if this is our pump our oil return pump or one of our fuel pumps. Now, if it's one of our fuel pumps, the fuel injection system or the fuel system is a supplementary system. So we're actually adding in the Hobbs switch. That way it's only active over 5 psi. Then basically all we do is on this negative over here, instead of going directly to ground, we're going to go to our Hobbs switch. Now, in order for this to work, we have to have both of our triggers active. So our injector has to be powered on, which means the ignition's got to be powered on. Our Hobbs switch also has to be activated, which means we have to be above 5 psi. So when this condition is met and this condition is met, then your pump will activate. So that about covers the amplifying side of it. Again, all we're doing is we're taking our input from the injector, which is a small 12-volt signal, and we're turning it into a large 12-volt signal, getting our supply from the battery. It's just going to amplify it so that way we can output and activate something bigger than what our current supply voltage is. The next thing that we're going to go over is going to be a power inverter. Or a signal inverter, rather. To give you a good example of that, most headlight systems or parking light systems, if you look at the bulb itself, there is one leg is grounded out. So it constantly has a negative to it. And in order for us to turn our lights on, this over here runs through to a switch. This is we'll call this our park lamp. So this is our park lamp switch. When we turn on the switch for our park lamps on inside your car, it's going to then allow plus 12 volts to pass through, going up to turn the lamp on. So when this switch is active, it sends a 12-volt trigger. Now, when we say a trigger signal, we have a constant that's there all the time, so the trigger is whatever signal is missing. Now, we could change this up. A few cars out there will actually have 12 volts constantly going to the light bulb. The problem, or the reason the light bulb doesn't ever power on is because now it's missing its ground. So if we turn on our light switch here and we pass a ground through, now we've completed the circuit again. This is what we call a negative trigger. Now sometimes we have a negative trigger and we want a positive trigger. Other times we have a positive trigger and want a negative trigger. One example for that is if we wire our nitrous system. When our nitrous system switch is active, it's giving plus 12 volts. And this is going to go to our nitrous solenoids here. So we've got positive, turn our nitrous system on, and now that activates our nitrous, and it sends plus 12 volts to it. This is grounded, so we constantly have a ground. This is going to be a positive trigger. But now, let's say we want to use our ECU to retard timing. So we're going to plug this signal into the ECU so the ECU understands nitrous is active. When nitrous is active, do something else. Retard timing, add more fuel, whatever it needs to do. The problem is, on our ECU, it doesn't understand 12 volts. It'll only understand a ground. So in order to trigger it, we have to feed it a negative, not a positive. So in order to change this signal from a negative, or from a positive to a negative, because right now we have a positive trigger, we need a negative trigger. We are going to wire up our relay so that way we have now our negative trigger is going to go right to ground. Our positive trigger, we're going to go up here and steal from our nitrous line. So now, on our relay, we constantly have negative. When we activate the nitrous through the switch, we get the positive that passes through. That's also not only going to go to the solenoids, it's also going to pass down to our relay. That's going to trigger our relay. Now again, this is just a pass-through here. So what we're going to do is pin number 87, we're going to come over here and we're going to ground pin 87. What that does is when this trigger is active, it's going to send the negative signal from here, our ground, right through the relay and then to the ECU. So now what we've done is we've changed our triggers. We have a positive trigger here, but with the relay, we change it into a negative trigger. The negative trigger can then go to the ECU, which is what the ECU is expecting. It wants to see a ground when something is active. And we've changed it into a ground. So again, the power from the nitrous here is your 12 volts is going to go hit this trigger on our relay. The other trigger leg is constantly grounded, so that immediately activates the relay. Pin number 87, we've got running to a ground, so that passes a ground through to the ECU. I hope this makes sense to you guys. But again, what we're doing here is we're changing plus a positive signal into a negative signal. And you could do the exact same thing in the exact opposite. You could steal a negative signal, have a constant power supply going here, and then pass through a positive. So that way when you have a negative trigger, you can convert it to a positive trigger. The relays are really universal. There is no polarity on them. You can kind of wire them as you please. Alright, now the last section that I'm going to cover on the relays today is going to be a logic. You can use these as logic circuits. For those of you guys that aren't familiar, that's and, or, nor, and, not. A couple different ways you can use it. Remember, these are two triggers here. In order for it to trigger, we have to have a negative over here. This is by far the simplest one. And a positive over here. Now, what can you do with that? Well, you could take this, again, going back to nitrous because that's the easiest, and you could run this through a switch on your throttle. So now we have a positive trigger here, and this is our throttle switch. This one over here, let's say we don't want it active all the time when we mash on the gas. We want to also be able to control it with a button on our shifter. That way if you have traction issues, you can hammer it off the line without spraying, get your traction, and then bring the nitrous in later on your command with your hand. So then we're going to add another switch, or a button rather, right here, that goes to our negative. So now in order for this relay to be active, which we're going to have our input here, and our output here was going to go to our nitrous. In order for this input to go to our nitrous and our nitrous to become active, we have to have our throttle switch on and our shifter button on. Okay, the next one that we're going to cover is actually going to be a NOT circuit. It's more of a deactivation circuit. Now this is going to take use of that fifth leg, the one that we haven't talked about yet, and it's the one that's more towards the center of the relay. Now, the way this relay works is when the relay is not active, these two right here are connected to each other. Once the relay becomes active, because you've given it both of your triggers, it switches to that leg there. So normally, we're using pins 87 up top here and 30 down bottom. And what that does is once we activate our relay, it's going to allow the pass-through to go up here. However, what it also does is the constant pass-through that's normally here, it breaks that circuit. That's what we refer to as normally open and normally closed. So this one here is normally closed. This circuit is closed and it's continuous until you activate the relay. This circuit up here on the top one on 87, between 87 and 30, is normally open. You close the circuit and complete it once you activate the relay. So sometimes we want to deactivate something. Now an example for that would be, again, I'm running nitrous. We want to connect it to our shift light. That way when my shift light comes on, it automatically shuts the nitrous off. That way I don't over rev on the engine, it cuts it down prematurely, and that way I can save the engine. Kind of like an RPM window switch, if you will. So what we're going to do with that is we're going to switch. Instead of using 87 that we have been up there, we're going to come down here and use 87A and 30. Okay? This is going to, our trigger is going to go to ground. So we've got a negative trigger all the time. Our positive trigger we're going to get from the shift light up here on the dash. Got our autometer shift light. Now when the positive voltage goes to our shift light to turn it on, we're going to tap into that and steal it. So, and that way it's plus 12 volts. So now when our shift light activates, this relay activates. Normally, we've got our nitrous signal coming in. And we're going to bring it in right here to pin 87A. Off of this, pin 30 here, we're going to go out to our nitrous, to our solenoids that we're activating. Now you can basically take anywhere along your electric nitrous circuit that you've created when you installed the nitrous, cut it anywhere, and splice this relay into there. And what it's going to do, under normal circumstances when that light is not on, you don't have both of your triggers. Since you don't have both of your triggers, the nitrous signal is automatically passing through. But the second you hit the set RPM and this shift light comes on, now you've constantly got your ground, you'll get your second trigger, your 12 volt plus over here, that's going to break that connection. So when you have this, you do not have this. It's what we call a NOT circuit. So once your nitrous is activated, it will deactivate once your shift light comes on. And you can use this to break up any of the, basically anything that you want shut off or normally broken on a circuit. You can actually split the signal and stop it from going to whatever it's going to, and you can run it off of any input that you want. All right, for the next section here, we're going to go over what's called a switcher. Now this one's a little bit more complicated, so if you guys aren't following along too well, you might want to go back and watch the first few sections over again. This one's one of my favorites. We implement this a lot when we do like hidden nitrous setups. What this is going to do is it's going to utilize all 5 legs of the relay. Okay? Now, we're going to say this one here is going out to a constant ground. This one here is going to our nitrous arming switch. And then from 12 volts. Now our arming switch is different than our activation switch. Our arming switch is basically just prepping the system to make the system ready. The common here, which is pin 30, we're going to run it's a really bad drawing, but that's our steering wheel. And we've got our horn buttons on it. So whenever we push the button here, it's going to normally, we're going to go off of pin 87A. And that's going to go to our horn. So under normal circumstances, when our nitrous is not active, we've shut this switch off. That means our relay is not active. We have a normally closed circuit between pin 30 and pin 87A. So when I push the button on my horn, it activates the horn. Now, when we arm our nitrous switch, now we have both of our triggers for our relay. So instead of working off of pin 87A, this horn button is now going to operate whatever is on pin 87, which is going to be the top one from our relay. That one's going to come down and activate our nitrous. So we're taking the signal from our horn here, and then we're splitting it. We're switching it around. When our nitrous is not active, it makes the horn beep. When our nitrous becomes active, or when our arming switch becomes active, that changes the relay, switches it over, and now it activates our nitrous. So we're using one button here, but we're making it operate 2 separate functions depending on what the condition of this switch here is. So it's actually transferring it and making it to do 2 different things. Like I said, this is what we do a lot with doing our hidden nitrous systems. That way we don't have to have arming switches, or I'm sorry, not arming switches, we don't have to have activation switches, throttle switches, things like that. We can actually hide stuff where it's using the factory wiring of the car, and up by the horn we're just tapping into where the horn is, redirecting the signal to operate our nitrous. And that way it's pretty sleek, it's pretty hidden, and you don't have a whole bunch of extra junk sitting in your passenger compartment that can be readily seen. So again, to cover it, we have a constant ground trigger. So our positive trigger is going to be our 12 volts from our arming switch. Without the 12 volts, when our arming switch is off, we're normally driving, the horn goes through to pin 87A and operates the horn. When we activate it, the horn goes through to pin 87 on top and activates the nitrous. So it'll switch the horn one horn between two different separate functions. Well, that about covers it for relays today. I'm CK with Under Pressure Power and Performance, and remember, stay tuned.